Hi, in this video we're going to create a MATLAB program that will compute the limit of a function and also computes limits in L'Hopital's rule. Alright, so let's look at L'Hopital's rule in my calculus book. This is the theorem 6 in this book. So it says limit x approaches a f of x over g of x is the limit x approaches a of the derivatives. So f prime of x over g prime of x. And this is one of the examples. They show this example, and this is what we're going to do here shortly. X approaches 0 of this function, and they get that it equals 2. So eventually we reach a point where we don't have to take the derivatives anymore. 3 minus cosine x over 1, and that's where we stop taking derivatives, and we plug in 0 in place of x, so it'll be 3 minus 1 over 2, and that's how we get 2. Okay, so let's go to MATLAB here. So what we're going to do is we're going to do this symbolically. So we say sims x, and here we just say limit. Let's make this, and then inside we're going to put in 0. That's generically how we would do it. We might have to change the 0. This is what x is approaching. This is limit with respect to x and what it's approaching. So let's enter this function. That would be 3x minus sine of x over x. So I'm going to copy and paste that over here. And then we run this, and we get that the limit is 2. All right. And let's see what, let's look at the book again. And it was 3x minus sine x over x. So let's do example 2 now. So limit x approaches 0, 1, square root of 1 plus x minus 1 over minus x over 2 over x squared. And let's go back to the code and let's put that in there. So we copy it and insert it in there. And we run this. That limit is negative 1/8. So let's do one more. This is now example 4a. So we put that in there, and let me see what this limit is with what x is approaching here. So it would be 4a in this book. So we go to example 4. So this is pi over 2. All right, so let's enter that in there, see what we get. So I'm going to do it this way. So pi over 2. And the answer is 1. And let's see if that matches the book's answer. It does. So the limit of the function approaches 1. Secant x over 1 plus tan x. And if we go back to the code, secant x over 1 plus tan x. I'm not going to do 4b. Let's jump to page 89 just to look at the basic limits and do one of those examples. So I'm going to go to page 89 of the book. So I have example 7, x squared plus x minus 2 over x squared minus x. X approaches 1 in here. So they get 3. And see if that's what we get also. So I'm going to copy that into my code. And this was 1, I believe. Yes. And we run this. That limit is 3, which matches the one here. So that's how we create a program that you can compute limits of any function, whether in L'Hopital's rule or limit section.